Hello, John here, and welcome to another stream. This is episode 3, I do believe, of the BASIC extension for graphics. In the last episode, if my comments are anything to go by, added basic tokenizer and lister functions for the new commands. So that's where we got to. So basically, if I run this, we should be able to encode our functions into BASIC. So SOS 64738. So I'll do a soft reset. There we go. So 10 graphic. And then if we list it, we've got graphic, but if we do memory, it should be encoded. So if we memory 0800, yes, we've been writing it from scratch. So as you can see, that's the basic line linker address. So that means the next line is at 0870, which is somewhere over here. Then line 10. And then CD is our tokenized keyword for graphic. So as you can see, we've now encoded our commands. So what we need to do now is we need a way to evaluate. So when the program runs, we need a way to evaluate what it sees and then to execute that end result. So there's two more wedge, basic, whatever you want to call them, routines that we've got to write and then embed into the program. So if I go here, I think it's here where the vectors are. Right, so we've done the tokenizer and we've done the lister, so it's these two here. So as it's known in the book, the by function and the evaluate my function. So they're the two functions we're going to write today, and hopefully we're going to write the error handling function, so that will handle all the custom errors we're going to generate. And then, if I have time, which I think I will, we'll start coding the commands up. So we'll start explaining how the graphics are going to work. I've got a slideshow and everything. You'll love it. We're going to try and write up the commands to draw points. So it's the plot command draws a point on the screen, so one single pixel. So hopefully we'll get to that point, and hopefully we'll get to the point where we can read the pixel back, called rPoint. So there are two commands that are in this thing called point and rPoint. So if you remember episode 1 when I showed you my operation manual, which I've put away now, where I'd made a manual of, that's hopefully where we're going to get. So in this stream we're going to try and do the evaluate my and the bye routine, or basically it's to execute the command. And then we're going to talk about how we're going to put the point, how we're going to set a pixel on the screen, write that function which is called point, and then write the function to read a pixel off the screen, because we'll need that function when we do things like fill, put in characters on the screen, and other bits and pieces where my memory escapes me. So as you remember, this is not a program, so to speak. This is not a program. This is a pretend cartridge. So we're writing it like we're sticking a cartridge in the Commodore 64 and then booting up. That's why I did the soft reset. The reason for that is because it allows us then that if we want to put it on a cartridge, we can put it onto the Easy Flash 3, blah, 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 and any other programmable cartridge that Commodore 64 uses. And so we're going to do the same thing to this like we did with Kaidos, the disk operating system basic commands. Make it a cartridge and then carry on. So what we're going to do first is we're going to, what's on my list on here? The bye-bye routine. Right, so why we do that one first? No, we'll do the eval one first. Right, so the eval routine, basically, when you run would be cool to actually release them. Release what, mate? Release what, Grey Defender? Oh, basic on cart. I'll have to see if we... I haven't got an EEPROM burner. That's the problem. I'll have to invest. I'll have to see what I can do. Because I've got the Easy Flash 3. It's over there somewhere. As you know, because I'm a cartridge collector, because I've just bought those two new ones, you know, the multi-carts that are still there. But I like to write them because it's challenging to write to a cartridge because you can't use self-modifying code. Can't do it. You can't do it. Yeah, I've got an Easy Flash 3. I actually reviewed it on my YouTube channel a long time ago when dinosaurs ruled the earth. Where is it? See if we can find it. A long time ago. Because I found all the things to program it with. Oh. Gosh. How many videos have I done? There's Kaidos. So there's the disk operating systems this season. Oh. Where was it? Oh, it stopped after 3 years. Oh no. There we go. There it is. Anyway, so we're going the eval, right? The eval function, basically, when you type run, what happens is BASIC hands over is the BASIC and the graphics cartridge going to be merged? Ooh, good question. I don't know how much space. I don't know how much space it takes up. Let's have on. Let's load it up. Core 2018. That's a long time ago. Let's just build it. Let's just build it to memory so we can see how much space it takes. Right, so we're starting at 8,000 and we finish at AD. Oh, there's not much space in there. There's not much space in there. We'll have no chance of putting it together. Because the cartridge, if you think about it, cartridge is only 16K tops. 16K, so we got 8K, sort of. No, we haven't got 8K. No, we have 8K, just over 8K. You never know. We might be able to do it. We'll have to see. We'll have to see if it can be done. Anyway, back to just having a squirrel moment there. Oh, the DO21, DO20 raster. Yeah, I've been messing around with that. Right, so when you type run in BASIC, it hands over to the Evaluator controller. And what the Evaluator controller does is it starts at 0802, and it starts reading the basic program out of memory. And that is the thing that looks after evaluating what it's written. So it reads a line of coding into the buffer zone, and then evaluates it. So we need to write our own evaluator. So let's get that started. So let's create a new file. What have I called it? Basic eval my, yeah. So have I put headers on it? Yes, I did. Let's copy. Right, so we need a vector, of course, so we need an address, so eval my. And what we're going to do is we're going to insert ourselves in between the run command and the basic ROM. So we're inserting our bit in there to find out if the command that's currently being read in is one of ours, and if it's not one of ours, then we'll hand it back to basic. So we're going to start with the accumulator being 0, and then we're going to initialize, I think that's the key, that's the keyboard, the keyword length thing, variable, because we need to find, you know, match up how many characters are in each. So first thing we do, we use I wonder if I've got that in my routines. Hang on, have I already got it in there? Is it in? Yes, it is. There it is. There's the beauty. Now this is a 0-page routine that BASIC uses. It's called character get, and it lives in 00070 to 00787, I think it is, and it's self-modifying code, right? So if anybody tells you that self-modifying code is useless, it's confusing and all that, Commodore did it when they brought out the Commodore PET. It was in there. Commodore VIC-20, it was in there. Self-modifying code around the 0070 function. Now this is 0073. If I go back, yep, 0073. So what that is doing, that is getting the next character. So it's telling the basic line reader to get me the next character. And then what we're going to do, it comes back in the accumulator with what it's got. So we're going to compare it with our base token code. And what I mean by our base token code, because have you noticed when I did when I typed in 10 graphic, it coded it to CD, and our base one is CC. All right, so we're saying, is it CC? Yeah. Then we're going to branch if carry clear. That means it's less than. Yeah. And we're going to branch away. If it's less than, we're going to branch away, and then we're going to go back to basic. Yeah, because it's not one of ours. Then we're going to compare it. Now, if I remember correctly, I think our top one is DO. I think it's DO. But we'll change it if it's not. So we're going to take CC, CE, GF. I think we had more than that. CC, CD, CF. I think we had more commands than that. I think this number's wrong. Because C, we've got more than 3 commands. It's going to be more like that. So then if it's greater than that, then it's not ours. Yeah. So we'll send it back to BASIC. And whoa. Then we know, because we've stripped out all the tokenized bytes of CC or less, we've stripped out EO or more. What's left is our core, our commands. They are our commands. So then we can say jump to by go. Now by go is going to be in our bye routine. Yeah. So that's going to say I have found a command that belongs to us. I need to go jump to the executor to execute our basic command. So now we need to do eval v, and we are going to load in 7a, which is part of the character get, character got routine, and we're going to check that it's 0. And if it is 0, we are going to decrease 7b. And if it's not 0, we are going to decrease 7a. And then we jump to basic. Now I think it's eval, there it is. Now what we're doing is we've just asked the basic interpreter for a character, yeah? And so what happens is it reads the character but then moves the pointer to the next character. And what we're saying is, right, this is the character that we've just read. The pointer is now pointing to the next character. All right? Oh, hang on. No, we've just moved to that character and read the character, so it's there. If it's...
Hi, John here. Another subscriber. Stay a while. Stay forever.
Hey, got a subscriber. Hey, Andy, 3 months. Hey, is it 3 months since I've been streaming? Oh, it's going to be 4, isn't it? Because I was streaming for a month before we could get you guys to subscribe. Oh my God, 4 months I've been streaming. Anyway, so back to this. So the basic interpreter was there. We told it to get the next character, which moved it to here. Yeah, we read that character. If it's ours, fine. We're happy, hunky-dory, that's where we want our character to be. But if it's not our character, we then have to hand it back to the basic interpreter. So what we've got to do is we've got to move the pointer back to where it was before. Yeah? Before we actually did our... Cheers, mate. And so we have to put it back to where it was before. So when the basic interpreter runs, it does the character get. And that's why we load in 7a. If it's 0, that means we've crossed over into the next page. So that means we've got to decrement 7b and then decrement 7a before we hand it back to the basic interpreter. So that's the eval. So let's add that to our command, which is here. So we'll copy that. So we're going to add it to our code. Eval my. Now I can't run it because there's no way of showing it. Yeah. The only way we're going to show it is by to write one of the command first. But before we can do that, we've got to write the executioner code. So let's do that. Inc basic and bye 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 bye. There we go. So let's get back to there. Right, so it is the 23rd today. Wow. Edit basic evaluator executional code. Oh, squirrel moment. Squirrel moment. Stacy, do you know when you said you wanted me to show you around Voyager in Minecraft? Yeah? I have got the Enterprise in Minecraft. I'm telling you, you can walk in it. It's brilliant. You probably don't want to see it, but if you do, I'll load it up for you so you can have a look. But I have got the... Oh, I'll do it now. Let's do it now. Let's have a bit of fun. It's only a quickie. I'm not going to stay in it for a while. But I've got the Enterprise. Because I'm using it. I'm using it as how they did it. Let me get me controller. But I'm gonna. It's good. This is me using inspiration from someone else. Yeah. So this is a guy that. Right. So he was working out all the fittings, but if I look up, look at that. Starship Enterprise. How cool is that? If my Voyager that I'm doing is anywhere as good looking as this, I'll be really, really chuffed. Right, I think you can get in here. Here we go. It's all kitted out and everything, look. But that's inside, yeah? But, right. So it's got the nacelles and everything. I don't know how long it took him to do it, but it's epic. And I'm going to use some of the textures he's done on here for Voyager, because I'm doing Voyager in the new Minecraft world that we've got. But how about that, eh? I mean, look at the shadow it casts. But this, inside, is all done. Right, there's an entrance there. Oh, it fell. Show us the bridge. Hang on. Let me see if I can get to it. I've got to find my way around. So we're on deck 7. Right. We've got to get to deck 1. Okay, I ain't found. I need an elevator. Hang on. Site-to-site transport, yeah. I need to get... Hang on, let me see if I can get above there. Because on deck 7... I mean, look. Look what's going on in there. There's the bridge, I think. No, that's the captain's quarters. Yeah, captain's quarters. Here we go, there's the bridge. Anyway, bit of a squirrel moment there. Where am I going? I'm going out here. So this is the Starship Enterprise in Minecraft, and I'm going to use it as inspiration to do Voyager. I mean, if Voyager looks anything like that, I will be chuffed to bits. Chuffed to bits. Probably were. I don't know. But it's like that inside because he's done it. He's done the top bit down there, look. Right, so this is the top of the deck. So he was trialing it out, look. Yeah. So there's the bridge, yeah. And then he's got all the, and he was trialing it out. Look, I mean, look at all this, and that's all in there. But there you go, Starship Enterprise in Minecraft. Anyway, squirrel moment. Sorry, Andy. It was a squirrel moment. Right. Anyway, back to this. So, yeah, it's going to take a while. I've worked out it's going to be just over 100,000 blocks for the Enterprise. Not the Enterprise, the Voyager. I've got all the schematics and I've all blockified them all. It's going to take me a while. Anyway, so we've done the evaluator. Now we need to do the executioner. Yeah. So we'll copy that. Put it in there. So this is the what they call the bye-bye routine. Basically, it means bye-bye. I'm finished with you. Bye-bye. So we want a vector and so when you hand it over to the executioner, it then needs to do the same check as the evaluator. Now, and the reason it does this is because it checks that, one, you have to check that you are meant to execute this command, because if it goes wrong, you need to pass it on. So we're basically doing almost the same thing again. And you're going to go, why are you doing it again, John? I mean, if you look in the code in Commodore, they do exactly the same thing. So we're checking it. If it's not us, we go to bye-bye RTS. And I thought it was wrong. I think we're up to that. The amount, yeah. If it's greater than that, by RTS. So now we're just confirming that these are our codes that we're are going to execute. Yeah. So JSR BIGO. So that's where we're now going to execute. If it's not, when it's finished, we're going to go to BAS new next statement. Have I got that in there already? Next statement. Oh, it's not in there. Right, what's next statement? Next statement. Where's my library? Ah, there it is. Right, so ROM routines. Oh, it's there. New statement. Okay. Did you guys see it? Oh, there it is. No, there it is. Aha. So what's happening is with JSR to BIGO, which executes our command, and then when it's finished, it comes back to here, which then executes the next statement on in BASIC. So we basically hand it back to the ROM to do its normal find the next statement, which is normally the colon. So BIGO is where we're going to execute our commands. Oh, this is annoying me. Right. So the first thing we need to do is we're going to subtract the low number from the command. So our commands are CC or above, so we remove CB, which gives us an index of 1 to something. Yep. Then we're gonna times it by 2 and then transfer it into the Y index so we can index our command array. And that's what we're going to do now. So command. So command address. So this is our high byte. Then we're going to push it onto the accumulator. And then we're going to get the low byte. And then push that onto the accumulator. And the reason why we're doing that is we're going to run the character get function, but instead of JSR into it, we're going to jump to it. So the RTS of the character get function is the return value that we've just pushed to the stack. Yeah, and so then it will go off to our function and then run. And then by RTS basically is doing the, so we're telling it to do character get, but this time character got, which means read the character again, read the character in the spot again, so it populates the accumulator, and then we just send it off to the basic executioner, which is called gone, I think. There we go. So we've now, are you still with me? Yeah? Are you still with me? Do you still understand what's going on? Because if you don't, now's the time to put your hand up. Yeah, okay. I don't know if I've shown you, but I'm reading this at the moment. Some light bedtime reading. Neural networks in Python. Right. So we'll add that to our root program. Instant sleep. Yeah, Some of us are afflicted. Executioner, I think that. So we've included bye-bye. Now what we need to do is we need to set up the vectors. And the vectors are in there. So get rid of those two, unrem those. So that is now activating our evaluator and our executioner. So we've got the tokenizer, the lister. So basically the cruncher, the decruncher, the executioner and the evaluator. The only other thing we need to do is the error handling. So that is basically the cart started. It's a case now of adding commands. Now, let me just check my notes on how we're doing this. Excuse me for a moment while I go and find them. So let's see. Screen command. Okay. Graphics and screen command. Okay. So we can start writing. We can start writing our commands. I'd like to do the error handling. What? Did it? No, it did not. Anyway. Right. I think we should write the error handler as well, because that's the other vector that we need to do. So we'll write the error handler as well. So let's add a new file, inc basic error handler. Let's grab that. So basically, the reason why we're taking over the error handling function is because we want to be able to have our own custom errors. Yeah. So if we create some variables. Now, if you're all shouting and saying, John, you're just picking numbers out of the sky, I'm not. Because they are, if I can find it, proper mapping the C64. They are proper values, and they are 22 and 23 are the error jumps. If I can find it. There you go. It's a temporary pointer. Yeah. It's a temporary pointer, and it's dedicated for this sort of thing. So if you want to use a 0-page function while memory's still resident, then you can use these pointers here, which is 22 to 25. So you got 22, 23, 24, 25. So you have two 0-page locations that you can use, and it won't affect any part of BASIC. Yeah. So if you're trying to do what I'm doing, then there's 4-byte location, 0-page byte locations you can use without affecting BASIC in any way. All right. So we're just going to use those as our 0-page lookups for the error handling. See if I can spell that right. Now, the way the error handler works is that, hang on, I wonder if it's better to show you E38B. Let me run Vice. So if we go into monitor and do disassemble E38B, first thing it does, transfer X into A, because when an error is generated, the error number is in the X registry, always the X registry. So when we generate an error number, we've got to put it in the X register. So they do a test for greater than 128, and if it's greater than 128, it just jumps back to basic. And I think the X value 128 onwards are not error codes. If that 7th bit is set, it just jumps back to basic. And I think a non-error is actually 128 or higher. So we have to do the same thing. We have to transfer X into A. Then I'm going to push it to the stack because I want to do a bit of messing around. Yeah. I'm going to branch if plus, because if the 8th bit is not set, I want to display the error. So we're going to say if branch if plus, display to the error. Going to bring it back off the stack, and then I'm going to jump to the basic prompt ready. So I've done it in reverse compared to what they did. So ready prompt, yeah. So if we've got an error that's 128 or above, we don't show it. We just go back to the ready prompt, that's it. But if it's less than 128, then we're going to display the error. Just display error. So we're going to compare it with 31. Now the reason I'm comparing it with 31 is we have already 30. Hang on, let me get this right. We already have 31 errors inside of the basic interpreter. 0 to 30. 31 in total. So we need to check that the error message that's being returned is not one of ours. So then we have to go branch if carry clear, and we'll send it to a ROM error handler. So it's a ROM error. So anything that's less than 31 is a ROM error, and an error that's generated by BASIC. So now we know that these errors 30, 31, 32, 33, 34 are our errors. So what we're going to do is set the carry, then we're going to subtract 31. So we're subtracting the number so we can once again use it as an index. So we're going to times it by 2, transfer it to X, and then we're going to load I'm just trying to think which way round we're going to do this. So we're going to load the text pointers. We're going to load the text pointers. So error codes, error code address, X, store it in error handler low. Yep. Then load error code address +1. So we're taking now the low and high byte of where the text is stored. Then we're going to pull back the original error number from the stack, and then we're going to jump to BAS custom error. Here we go. So that's setting up the jump vectors for the error message, and then we're going straight back to the ROM and saying, there you go, print it. Yeah. So we need to sort out the ROM error. And the way to do this is we're going to have to revert the that's a point. That is a point. Is that a bug in my original code? Okay. Right, ComScreen is a function that I'm going to create, and what ComScreen does is it takes it out of high definition graphics mode and puts it back into text mode. All right, so we'll get to that. That's why as soon as we've written this, we won't be able to run it because we haven't got ComScreen. Then we pull back the accumulator because it's still pushed. Yeah, push, jump to here, compare it, jump to where. Yeah, so we pull it back, transfer it back into X, and then we're going to jump away to the ROM basic area. So we're going to say, right, there you go, it's a ROM error. Go back to basic and handle your own error. It's not one of ours. So now we need to create our array, which is here. So, Word. Let's put a to-do. Now, I know what error codes we've got. But I don't want to put them in here yet. But what I will do is I'll put a placeholder to show you how it's going to work. So error code 31. Word error code 32. Shifts. Right, so there's 3 errors. So there's 3 custom errors. So first things, we have to define error code 31. So this is going to be a text. This, oh, no caps, John, come on. This is error 31. Oh, I can't do that. I'll show you in a minute why. Right. And the reason I can't do that is because it's got to terminate on a bit 8. So we'll say this is error 31. Like that. Yeah. So we'll copy that. TW capital O. THREE capital E. So make that 2, make that 3. And that's how the basic error function works with the text. What it does, it'll read the bytes and then print them out on the screen until it comes to a byte with the bit 7 flag set. Now, to get the bit 7 flag set in the Commodore 64 is the shift and the character. That's bit 7. And that's why we've got the capital E, the capital O, and the capital E there. Yeah? Because that means termination of our string. So we've then why have I got the syntax error in there? I must use the syntax error. So I've put in the syntax error. I don't. Is that an actual number? Is that an actual error number? That's probably why I've not. That's why probably why I put it in. Oh, used to Python. Excuse me. Right, I assume I'll have to check this, but I'm going to put it in anyway. Oh, we're jumping, doing the, okay, we're actually performing the jump. Right, that's here. So we're getting rid of that and we're putting that in it. Just make sure that that is that, which it is. So we're doing the actual jump there. Is that in the book? Basic ROMs routine. Where's my basic ROMs? Yeah, there it is. So I'm jumping. So the syntax error is jumping to mine. Oh, okay. When we get to the part where this comes in, I'll probably understand it. Right, so that's all the jump vectors done. So there are all the basic jump vectors done. We've done the error handler. This is direct mode, so we don't need to do anything with that. We've done the tokenizer, the detokenizer or decruncher, whatever you want to call it, lister as I call it, the bye-bye and evaluate me. So they're all the vectors all done and their corresponding routines. So it's writing code time. So let me just, what's next on the list? Right, so the two commands that I've got next is setting up the graphic screen and then setting up the text screen. So we're basically going into graphic mode and screen text mode, or screen mode as I call it. Now let's just make sure, yeah, that's the graphic function. So I've got a presentation what we do to set up the high-res graphics. So if you're up for it, welcome to my lecture hall. Toughest levels, and I didn't even get to his levels. I'm still stuck on level. I haven't even reached my own level yet. I think that's level 13, yeah? I ain't even got that far. Anyway. So, presentation time. Here we go. Oh, back one. Oh, screwed up. I need to relax. For your on John. What? Anyway, so as we all know, the Commodore 64 VIC chip can only read 16K at any one time. Yeah, it's only got 14 addressing lines. So, which means that it can only address 16K in any one shot. So the 64 memory is split into 4 banks. Each bank has 16K. Now, to address the entire 64K, you've got to then tell the VIC chip first which bank you want to use. You know, so is it bank 0, bank 1, bank 2 and bank 3? And the way you can do this is we have what's known as addressing modes, yeah? And we have 2 bits. You have to address populate somewhere else in the CIA. Then we have 4 bits that you actually tell the VIC2 chip, this is where I want to go within that 16K space. And then the rest of it is what you can control. All right. So how do we populate the 2 yellows? Now this is in general. This is in general. All right. This is the golden rules of high-res graphics, character graphics, and all that. This is what the VIC chip is, and this is what a lot of people struggle on, is how to set up yes. And this is what a lot of people struggle with when they're trying to use, you know, custom characters, sprites, you know, which memory bank is my sprite in? Oh, I put my sprites at memory at location 8000, but I can't see them. I just get garbage. Yeah, because you're still looking in bank 0, which only can address up to 4000. So you need to tell the VIC chip you're in bank 2, and that sort of thing. So how to set these 2 bits? Well, we have to set the first 2 bits in DD00. DD00 is CIA 2, I think. Correct me if I'm wrong. I think it's 2. And that basically you put in 00, 01, 10, 11. But you know, this is Commodore. This is, you know, it's not as straightforward as just putting 00 for bank 0. Yeah. Shut up. That's getting on my nerves. Right. So 00 doesn't mean bank 0. Commodore threw a spanner. You have to invert. 00 means bank 4. Bank 3. Yeah? 00 is bank 3. 11 is bank 0. So you've always got to invert what you think it is. Yeah? So if you want bank 0, which would be 00, you've got to invert it and make so it becomes 11. Bank 2, you would think is 01, but in fact you invert it, it becomes 10. Bank 3, you would think but it confuses people. It confuses people that because of this fact, you think, you know, typical addressing, you know, 0100 would be 16384, but it's not. It's not, because you have to invert it. So by default, bank 0 in DD00, the first two bits are 11. So if you want bank 2, which is at 8000, you would think it would be 10, but it's not. It's inverted, so it's 01. So there's your first 2 bits set in the VIC2 addressing system. The next thing is the next 4. Now these 4 bits are governed by the VIC chip itself, which is D018. Now these are not inverted. Let me just stress that. These are not inverted. So you are now addressing the K markers. So if this was 1000, that means you're effectively addressing 1024. Yeah? And all in the VIC 2 chip. So if this was 1000, then it would be 1024 here. Yeah? So that would be the first video addressing line. So 1024 is 0400, and that's where the screen is by default because it's set to 1. Now if you do 000, that means the screen would be set to location 0 up to 0400. But the problem is you've got 0 page in there. You try changing that, the screen goes mental. But if you was in a different bank, then you could use page 0. Then the rest of the number is worked out like this. So let's say we want our video to start here at 8400. Yeah? So first things first, DD00. We want bank 2. So 10 equals 2. But you've got to remember it's got to be inverted. So it's 0, 1. Then we are looking at 8400, which is page 1 in the 16K page boundary. So we set D018 to 0001. If you wanted 888 8C 9, if you wanted 9, then you're looking at 4. So it would be 0100 if you wanted to say the video starts at 9000. So when you've worked out these two numbers, that is where your video starts. So in this here, 10, remember it's inverted in real life. 0001, all the zeros equals 8400. So that is where your video memory would be placed. With this configuration, it would take this space up in memory. Are you with me so far? Yeah, because this can get really, really complicated. Right? So this is the video. This is where we're going to assign the screen. This is... Hey up, I got some bits. Thank you, Microman. Okay, so this is just the video part. Yeah, this is where you're telling the VIC where to address the screen itself. Yeah. The next thing is the character set. Same thing, different slight character, different point, because the way it uses it is there's another address. Yeah, if you can see, we're now addressing this part of D018. Yeah, so the first 4 bits was for the video address. The last 3 bits are used for the character set address. Now the last bit, forget about, because that's always set to 1. Pain at the backside, but that's always set to 1 for some reason. And it's the same logic. So you set DD00, which sets the bank, right? Then the 3 bits, so bits 1, 2, 3 of D018 is the next 3 bits in the address bus for the character set. This one is always set to 1. I think it's to do with the character ROM. I think that's where the character ROM would be. So in this case, in this particular scenario, we're saying we want to put the character ROM at 1000 here. Yeah, so the character data, which effectively blocks off this. All right. So the same as video, but using a different part of DO18. And that is how you set the video modes up. So with that information, we can be deadly. We can be destructive. So the first thing we're going to do is we're going to write the graphics command. And what I mean by that is, let me... No, these slides were going to be used in the video series that I was going to do, but I decided not. I decided not to record them as videos. I decided, yeah, I did those slides because the next slide down here is the next episode, part 4. Look. So these slides were going to be used in the video series, so I'm using them in the stream instead, because I'm not recording a video series, I'm recording streams. So here we go. The first command we're going to write is to set up the screen, and I'll show you what I mean. Hopefully my Vice is still pointing to my... No, it's not. Where's my stuff? My 64 files, not in there. F drive. There we go. Where's the 64 master? Where are we? 19, that's the one. 19. So this is what I wrote back in 1985, as I showed you. Yeah, I used the same templates and the same style because the feedback I got from... You're thinking of how I did the how I explained the different addressing modes in 6502. You wasn't even born in 1985. Okay, now you're making me feel old. Anyway, so this is what I did back in 1985. Now the command we're going to code is this, graphic, right? And basically, if I run it, oops, thank you, Microman. I'm a firm believer a picture is worth 1,000 words. So if I run it now, this should go the computer into graphics mode. There you go. We are now in graphics mode. Just a blank screen. Behind the scenes, I'm back at the ready prompt. I'm back at the ready prompt. So, it's flashing. But because the way we've set up the VIC chip is the screen is out of the way and all we can see is the color RAM and the graphics. It may have been about 70. I was going to say, I mean, in 1985, I was, yeah. 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 I'm not going to admit that. Right. Less than that, mate. No, 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 no. What are you saying? I'm that old? You cheeky. Now you're just being silly. I was 15, 16. 15, 16. Yeah, I'm a 66er. So that would have that would have made me 18, 19. Doing my A levels. Right. He was 16. Sweet 16, yeah. I hadn't heard of girls. I was too busy on the 64. Anyway, that's just my sad story. Right, so now we're going to start writing our commands. So the first command we're going to do is how to set up the graphics screen. So here we go. Now we're getting into the nitty gritty. So graphic command. Right, let's copy that. Put that in there. So we don't need that for the moment. We don't need that for the moment. We don't need... Oh, we need that. Don't need that. Go away. Don't need that. We need that. Probably need that. We don't need that. And we don't need that. By the way, as you saw, I am commenting it. So when it goes onto my GitHub, you'll be able to see it. Right, so we are graphics routine. And the way this works is you type the word graphic, or if I remember, it's G Shift R. We'll try that when we do it. So this is our graphic command, yeah? And the whole point is this sets up the VIC chip into high res graphic mode. Right, so command graphic. So the first thing we need to do is allocate some 0 page space for ourselves. Now, I just want to make sure, have I already got them set up? I can't remember. Ah, yes, here we go. RI buff, here we go. So I've already set up some memory locations, as you've seen by here. So I've got a 0 page one, which is F7. And we've got, starting at 02A8, I've allocated some variables that I think we're going to use in the future. So we set up our 0 page location. And what we're going to do is we are going to put all our high-res graphics here from 8000 onwards. So our high-res graphics are going to sit underneath BASIC. all what you see is actually sitting on top of BASIC. So there's the BASIC ROM, and our graphics RAM is going to be underneath it. And this is the clever part of it. Because the reason I put it there is because all we lose is 8K memory to BASIC. All we lose. Now if we'd have put the high-res this high-res portion in bank 0, it would have taken this up and we would have lost a big chunk of BASIC memory. And I'm waiting for you to go, but John, how do you do that? You will find out. This is where I was clever. I was too clever. It took me a while to get back into it. Anyway, so the first thing we're going to do is we're saying our graphics area is at 8,000. So the first thing we need to do is we need to clear it out. We need to clear whatever's there out. So this is what we're going to do here. LDY 0, transfer Y into Y, and then store it in BRIBUF, Y. Inc. Ooh. So RIBUF+1. So this is just clearing out the graphics memory, right? And so we're going to load. Now that can be done better. So I'm gonna change this now.
Someone's hosting my stream.
So that's,
oh, next thing they'll be nicking my code.
oh right. Someone hosted me. Cool. Hello, Mr. Oakley. Oh, thank you, Andy. WauloK, morning. Hey, oh, great. Oh, thanks for the bits, Mr. Defender. Right, so this is how I wrote the code as a kid, as a 20-year-old or 18-year-old or whatever, 85, 18, 19. So we know better now, right? So we're going to do this. Branch not equal, boost that. There we go, that's a bit better. In fact, oh, that'll do it. No, that won't do it. That's, yeah. That goes there. There we go. Sit. Less bytes, quicker. Ah, thanks. It's not my fault you've only just woken up. Right. So what we're doing is testing for C1000 because that's where our graphic space is. So we're occupying this space here. So we're clearing out this memory space to 0 from A1000 to C1000. So that's what we've done. The next thing is now we need to set up the VIC chip. So the first thing I did, like I showed on my diagram, we need to load the CIA2. Yeah. Then we're going to OR it with the reverse of 1 0, which will be that's set. We're going to set the direct. Hang on. 1 2 3 4 5 6. So this is set in the direction CIA2. So we're setting the CIA chip to be output, and then we load the CIA to port A, and then we AND it. Oh, am I loading them in? Have I loaded those in? Right, I don't think I've got them in there. Okay, we will do that in a second. So we're going to AND it with 255 minus CIA to PRA underscore VIC bank mask. Then OR it with what we want to do. So CIA to PRA VIC bank 2. So I haven't got those in this, so I'm going to add them now. Inc. What have I called it? VIC chip locations. Right, grab all that lot. Have I? Oh no, I'm going to say that's new. So this is the VIC chip locations. So they're all the 0 page locations of the VIC chip. And the other one, excuse me, is, where is it? Is it in here? I can't remember. No. It's in the CIA somewhere. Where is it? There it is. So creating another one. And this one is Inc. CIA. Where is it? Chip locations. So I've done all these. I've already done all these locations. Let's just grab it. Put that in there. There we go. So there's our VIC banking area. So I mask everything out except for the last two. Then these are the bank constants, for a better word. Right, so let's put them in here. VIC chip locations. Put the CIA one as well. So when it assembles, we should be okay. Yep, right. Let's go back to what we were doing. Whoa. Right, so we load. First we put the CIA into output. So output mode, not input mode, because you can have it, you can set it both ways. So if you set it to 1-1 on these 2 bits, that says they're going output. We're sending signals out. If it was zeros, it would be reading in. And then this bit loads port A, masks off the last 2 bits because that's all we're interested in, and then ORs it with the VIC bank 2 that we want to use, which is the A1000, and I can't spell for toffee, and no one picked it up. And then we store that back into CIA2. So we've set up the CIA chip. So we've told the CIA chip which of the 4 banks the VIC chip is going to use. Now we need to tell the VIC chip which part of that bank we're going to be using. So we are loading in VIC 2, and this is video memory and character set base. Are you impressed that I remembered that? And I don't think I've got any setup for that. No, I haven't. So we're going to OR it with #8, which is basically change VIC chip video address to 8, which is 8,000. Somewhere here. All right, and then store it back. Right, then we've got to put the VIC into extended color mode. So we need to change the scroll address, OR it with I've got this set up VIC2 underscore SCOLLY underscore extended mode, extended color mode, and then store it back. So that sets up the extended color mode for, which also sets up, if I remember correctly, the the graphics mode as well. Then what are we doing now then, John? Oh right, okay. Okay, then we are blanking screen. Now let's do this properly. Graph blank screen. So LDA #1, store it in 8400, Y. So this is where we've put the screen 5, 6, 7. I and Y, branch not equal to graph underscore blank screen, and then RTS. That's it. That's the code to put the 64 into high res bitmap graphics mode. So we need to add this now to our bye-bye. Yep, so I could. So we need to, where the command address is, and I'm trying to remember where I've put it. It's not there. Not there. Must be in the cruncher. There we go. Right, so the command address here, and then we are putting in this. Ooh, undo. So it's screen, so word 0, that's for screen. This is graphic. John, why are you doing that? Hang on. Let's put it in word that. We'll just swap these over. That's it. Now, you've got to remember. Thanks, Stacey. See you next time. You've got to remember, in the executioner part, we push the address to the stack to give this, to fool the 6502 that it's returning from a Go sub. Now, the way the return from a Go sub works is you do not push the address itself to the stack. You have to push the address -1 to the stack, because when an RTS happens, it pulls from the stack where the RTS, where the next address, that was it, the next address. So it's moved on. So when it evaluates the JSR, it moves on and then stores that onto the stack. So you have to bring it back, yeah? So we want it to bring back, so when it returns back, it jumps to the right location. Right. So what we need to do now is we need to add, we've added it into our, and we need to add it to our function list. So that starts at 8,000. So this is where our commands are. So we'll put the commands in there. Ooh. Right, so inc ASM, and we called it, where is it? Graphics inc graphic command. So this is our very first command in this software now. So if we build this and run it, we should, fingers crossed, have no errors, which we do. And it's complaining about, is that a missing reference? Invalid word. Okay. What have I missed? Have I missed? Oh, I've missed putting it in, haven't I? Ah. Inc. Where is it? Basic. Right, let's try that again. Try that again. Oh, no. I'm going to have to look at the assembly and find out why it doesn't like putting a space between the comma and the Y. Anyway. Is it still erroring? JSR com screen. Oh, yeah. Okay, right. Let's rem that out. Because it's not written yet. We'll get there eventually. Here we go. Right, so it's loaded in. So we're going to pretend that we're switching the cartridge on. So soft reset. Here we go. So we've only got the one command in there. So let's do it. Graphic. Right. List. And it's not stored it. Ah, it was working. It's there. It's tokenized it. There's a problem with the lister. Lister, is it because we've swapped them over? Command list. Can't because we swapped them over. No. Okay, what have I done? Lister. Let's just check the vectors. Error, normal, token, lister, bye-bye, eval. Yes, that's all working. Right. So it's there. CC is graphic. Right. Run. So it's right. We've got a problem. Problem. The lister worked before. So what have I changed? Let's swap them over. I got a sneaky suspicion my cruncher's not working very well. Tokenizer. Swap them over. Put it back to how it was. So that one would be word 0. So reset soft. 10 graphic list. Oh, this worked before. What have I done? I've broken it. Ugh. So they are going to my functions. That's the error. The crunch is working, because if we do memory 0800, yeah, it's CD now, so the crunch is working. So that's error. Reset, that's the cruncher. That's the lister. 8219C. Well, let's put it back to what it used to be. Hang on. Let's rem that out, rem that out, rem that out, rem that out, rem that out. And where is it? There. So we'll just put word 0 there for the moment. Oh, come on. F5. I must be missing something. Yes. Come on. Right. Yeah, it's because of the error handler. It's because of the error handler. So this is what it was before. So we'll just copy that. E3 8B. E3 8B. That's where it was erroring. F5. It was doing the error jump, and it, because I set it to 0, it jumped to 0. There we go. Oh, this worked before, when we finished. I have completely screwed something up here. I didn't touch the lister, did I? I would say no. I think my list has... Something's gone awry. It's tokened it all right. Yeah. Something wrong with my lister program now. What have I done wrong? Right, let's load this in. Where's C64 debugger? Well, that ain't loading in right. Oops. You guys can't see that, can you? Don't cross the streams. I'll try not to. Right, Control L. No, Control O. Where is it? Right, let's see if we can 8.1. Let's find out where it did it. F5. So the lister should be at 8196. Which is there. So we'll break it there. Okay, so 10. Why have you stopped? Oh, got a breakpoint there. Right, we'll get rid of that. That's it. Graphic. List. What? Now, that didn't do it. It's just typed the word in graphic. That is because I forgot to do this. There we go. Yeah, that's where it's erroring. Okay. Why would it be doing that? What it's doing something, but it's not. It didn't go into the lister. So it's erroring somewhere else. Yeah, but I also think because I've forgotten something else, haven't I? Yeah, right, hang on a sec. Right, so A7, E4. And before it was AE8, AE86. A E86. I think that's why it was erroring. It's because I forgot the other two vectors. Right. Right. Lister's now working. Right, the lister's now working. So, that means there's something wrong with our evaluator or cruncher. So, let's take them one step at a time. So if we put the evaluator back in and go into the cart initialize, we will rem that and undo that. It could be, what's he complaining about? Alright, yeah, it could be. Let's just look, let's just check them. Where are we? Evaluator. Let's just check it. Because the thing is, right, because when you run list, when you type the word list, I'm supposed to hand it over. Because it's a command I shouldn't be handling. So let's just make sure I've got this right. So CC is our number. Branch if carry clear to here. Oh, hang on. Whoa, whoa, whoa. Hang on. Where's my tokenizer? CC, CD. Right, okay. CC, CD, CE. I think it's this routine here. I think it's this routine here because this routine handles direct mode, alright? And it's direct mode that's the problem. And I think because I put E0, right? I think it's taking some of the direct mode things from commands away. So what I'm doing is I'm just putting it to how it should have been. Oh, that didn't help. Because there's only two direct commands in this, and that's screen and graphic. Yeah? So, tokenizer. So these two commands here are the only two commands that can run in direct mode. So where you can type in the word graphic and it pops up with the graphic, and type the word screen to bring it back. All the other ones you can't do in direct mode. You can only do them in program mode. And that's why these numbers are different, because CC is screen and then CD is graphic. So what I'm going to do is I'm going to just swap them over, because I want screen to be first. So we'll put that back in. We'll put this back in. And we'll put that back in, because I think it was the direct mode evaluator was wrong. I think it was this that was falling over. And the fact that I was missing the 3 off the end. Because we want to, the first 3 bytes, so it would have sent it through again. Now, I am pretty confident this is going to work. Pretty. Not 100%. Well, it assembled alright. No thank you, because I forgot something where I can't. Right, so we'll rem that out, bring that back in, bring that back in, rem that out. Yep. Right, here we go. Do a soft reset. Oops, no, soft reset. 10 graphic. We'll just check that it's tokenized it all right. Yep, CC. Right, list. Ooh, it's definitely that evaluator. Missed that one as well. Subtract, yeah. Ugh, not even following my own instructions. Make life difficult for myself. Right. Was it Alt and R? Yes. Thank you. Right. Right then. Let's see if we run this. Do we get a blank screen? I hope so. Well, we're in the right ballpark. It didn't clear out the memory though. So, oh, that's adding up. And our graphics. Right. LDA 0, store it, increase, go back. Increase +1, compare it with 0. I think cleared the screen out okay. But I don't think it cleared out the memory right. Let's just make sure. Oh, what? Yeah, that's the high-res graphics set turning on. Why am I... Okay. Maybe turning the wrong bit on. Alt R. Nope, that definitely was wrong. Put it back, John. Put it back. Put it back. Trust your younger self. So why is it not blanking the screen? Right. Let's run debugger. Let's find out what we're doing. Is that on the screen? Yeah. Did that load in? Right, run. What's it set to? Oh, no, the bitmap's in the right area. It's set to and it's set the screen to the right place. So the bitmap's in the right place, the screen's in the right place. Okay. Let's build this again. Right, it's load, isn't it? Right, so we are set in the right, this is the right bitmap area, but for some reason we're not clearing it out. Right, so where is... Let's have a look at the dump. I want to see... Open file location. Yeah, I'm just going to find the dump. Here we go. Open with notepad. No, we'll do that then. Here we go. Right, let's find where the command is, and then we'll put a breakpoint on it. Right, so there's the command. So the breakpoint. So we're going to put a breakpoint 828D. Eight to 8D. Right, so that's where our command is. Yeah, so we will load it back in. Why is it not typing? Right, here we go. Run. So it should break point here now. There we go. So it's we're break broken into our function. So let's see what it's doing. Hello. Thank you. So we're loading the pointer, loading Y, loading 0, storing it. So we're now blanking it out. Cool, this is going to be a while. In fact, we'll put a breakpoint there. So F11. Right, that should have blanked out the entire memory space. 5, 4. Is it 2? Aha! 2. So this should have blanked out our entire memory space. But we won't see it because ROM's on. Okay. I wonder if that's turned it off. Right, there we go. So I've turned BASIC off, and it's doing A1s, A2s, A3s, A4s, A5s. What on earth is that doing? Oh, you are joking, John. Oh, you complete and utter plank. Where are you? Yep, I'm a plank. Complete and utter plank. Right. So we're still, so now we should have a blank screen. Yes. Right. So that's now set up the VIC chip into high-res bitmap mode, with the high resolution graphics sitting underneath BASIC. Yeah. So the basic ROM's still on top. We're still, the basic ROM's still on top, but the VIC doesn't see the ROM at all. It doesn't see ROMs at all. All it sees is the RAM. So all it's seen is what we've wiped out underneath. But the 6502 only sees the ROM. Yeah, it can't see the RAM underneath it unless we switch it out. So that's why I am using the high resolution graphics underneath BASIC, because I'm not using any memory that's not available to us. It's just available to the VIC. So what we're going to do before I finish is we're going to add the reverse of the graphics command, which was the screen command, which allows us to put the screen, the 64 back into text mode. So we'll do that, and then we'll call it a stream with a typical old school coder cock up. Oh dear, a plank. Right. So the screen command. So let's get the graphics graphics. Here we go. We'll copy the header. Put it in there. So this is the screen. Routine. Syntax is screen or S shifted C. Right, so com screen. So we'll keep the naming convention the same. So now we have to do the reverse of graphics. Yeah. So first we need to set up the CIA chip. So we're going to tell it to put. We're going to put it into output mode. Right, so that's set the CIA into output mode, and now we're going to send out the memory block that we want to use. So we load the CIA to port A. We'll mask it off with 255 minus CIA PRA Vic Bank mask. I think that's what I called it. Then we'll OR it with what we're going to put it back to. So it's bank 0. CIA PRA Vic Bank 0. So now we're putting it back. So we're telling the CIA to tell the Vic that it's in bank 0. So we've done that. So we've set it back to 0. So we need to now put it back into text mode. So that's in scrolly. Missed an R. And it with Vic to scrolly normal color mode. Store it. Right, so that's that. Then we need to then put the video memory address back to normal. So Vic to video memory character set base. So we set the CIA chip to be output only. We mask off the last 2 bits, set it to bank 0, store it back, put it back into normal text mode, and then put the video address back to 0400. That should be it. So what we need to do, we need to add the command to our list of commands. So tokenizer, there we go, screen's there. So word com screen -1. Now remember, direct and oh, what's the word? Direct and run commands. So basically, program. Thank you. So these 2 commands are direct and program commands, but the rest of them are program commands only. Right? And that's why the evaluator is set to these two because effectively this is token CC and this will be token CD. So in the evaluator, CE is what we don't want. Right? So so we've put that command in. We need to include it in here. So it's a screen. Right, so here we go. Ooh, error. What we got? Oh, have I? It's the CIA, wasn't it? CIA. Let's get rid of that. Let's get rid of that. Keep that. Don't want that. Don't want that. But I want the CIA. It failed on the CIA, didn't it? Yeah. Bank 0. Bank 0. Right. Copy that. Oh, missed the 2 off. We'll do the other one as well. Oh, I've missed an underscore, haven't I? Yeah. Right. F5. Control R. So now we have 2 commands. Yeah? So 10 graphic 20 for I. Oh, what's the equal? Oh, what's the equal sign? God. Ah! $30, and then we'll. Right. So what we're going to do is we're going to put it into graphics mode, stall it for 2 seconds, and then put it back into text mode. All right? So here we go. Run. Now, if I get rid of line 30, I get rid of line 20. So we just got the graphic in. If I run this now, that has now come back. Yeah, that has now come back to basic. So if I press enter and then type my name, then down to and press enter, you can't see anything on the screen, but I'm actually typing it in. But if I type in screen, yeah, press enter, it comes back. Look, graphic and screen are the only 2 direct commands. Yeah, so graphic, let's see if that works. There you go. So graphics put me into graphics mode. And then if I type screen, oh, screen. Oh, I didn't type. I can't have typed in right. Enter, 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 enter. Screen. Oh, it's crashed. Has it crashed? Graphic. Now I don't know what the screen's doing there. Right, let's go into debugger. Let's find out what's going on. It should work. Yeah, I'm thinking it's come back with a syntax error. Let's fire up C64 debugger. Right, load. Okay. SYS 64738. Right, so graphic. Oh, let's put it into that mode. Is that one? No. That one? Yeah. Right, so graphic. So it's in graphic, so we will change it back to turn bitmap off, text, and then put it back into the normal space. Whoa, I need to change CIA, don't I? It doesn't like me. Change CIA. Which one's that one on? Aha. Can I change the port? You can call me if you want. I got my phone. Can you change the... All right. There you go. No error. But like I say, you know, 10 graphic run does it, then screen brings it back. Let's just keep an eye on what's here. Right, run. So port A goes to 97, but I don't think we can change port that port. We can't interact with the port. So it's 97. So if I type in screen, it's 95, it comes back. If I type graphic now, I'm also watching the PC counter. Those big followers are back again. Oh, it's in an infernal loop. It's in an infernal loop. Oh, it's going through my error routine. OB. Right. It's going through my error routine. But for some reason it's not Right, okay. It's looping round and round and round through the error routine. So what's going on here? So it's coming to, oh. Ah. Right, let's try that again. Right, graphic. So it's going through the error routine, and because I wasn't putting the screen back into normal mode, we didn't see it. There you go. So it's looping through the error routine. So now we've got it to come back. So why is it looping? So what is it doing? It said it was D, which is less than mine. So it does this, brings that, jumps. I bet you I've missed a 3 off again. Oh, you are kidding. So it's doing a syntax error, I think. I think D's syntax error. So it doesn't like. I'm just wondering if it thinks it's something else. 4738. Right, graphic. Here we go, syntax error. That was the problem. That'll be interesting. Did my original one do it? Attach. Load. 19. Command and 1. Graphic. Oh yeah, with exactly the same error message. Error in 1876. But it doesn't error in program mode. Well, I never. At least I'm consistent with my error messages. Yeah, I think it's... What would it be? Because it doesn't do it on screen. So it must be something to do with the CIA chip. Alright then, I'm just... Right. Where are we? We can do something. Maybe F7. F7. Is F7? F5. Oh. Oh, so I'm using Oh. Oh. Okay. That's okay. Okay, let's do that. And do the opposite. I wonder if it's because of that. It's the only thing we're affecting. F5. Nope, so it's not that. So it must be something else. No, it do, anyway, I'm not bothered about it because it works in program mode and that's where it will be used. So that's where it will be used. Because why go into, because you can't do a draw, so you can't. Yeah, I mean it didn't do it. So I'm just wondering if it's the. I mean, the only reason I've got those two modes in direct mode is just for this one, is that one really. Yeah. Yeah. That blanks the screen up in 8400. Well, I'll show you what happens if you don't put 01 in, yeah? Right, so pick a number, any number. Okay, whatever. There you go. Right. Right. This what happens if you don't. Right. So this is what happens if you don't put 01 in. So we've put that number in. Graphic run. Ready? That's why you put 0 in. And okay, so and the screen one. So that's there. So that wipes out the memory, and then this one, 69. So I've shown you it blanking out the memory. So this is now the screen part of it, yeah? So 10 graphic. There you go. Turn screen, goes green. Oh my God, what are you guys talking about? And that's why you put 01 in, because 01 makes it white. So we could have a yellow background, a pink background, but I bet it could do white. So that's why we used 01, yeah? So if you don't want to use white, then you just give it a different colour. So it reflects the 01 is white, isn't it? So if we did 0, it would come out black. Yeah? So we'll put it back to 01. Now, when you go into bitmap mode, your screen becomes your colour memory. It's weird. It's really, really weird. Because what it's doing, it's setting the background colour of the screen. your D800 onwards still sets the colours, so you could still have the colours, but because I've made them all black, it will be all black. Right, so we've managed to, where are we? Right, we've managed to do that. Evaluator, executioner, graphic and screen code. So that's today's stream, where we have implemented the start of our basic so we've implemented 2 of our commands so far, graphic and screen. Next time on OSK Basic, what are we doing? Oh, plot and R point. There we go. So they're the next 2. Part 4, plot and R point. So now basically what it is we're going to be creating a command to put a single pixel on the screen. So we can then use that plot function for everything else. And R point is read point. It interrogates that pixel. Is it set or is it not set? So thank you very much for joining. I hope this has been informative. It's slightly different than game coding because this is application coding. This is doing it a different way. And I'd like to say I don't want to do another game until later on when we get to Hunchback. So this is the 6502 code project, because we've got Grid Runner, which is the game, and I've shown you the Pi Runner. So and also you had a bit of Minecraft. How about that? Bit of all sorts today. So is there anybody online? Anybody on? I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.